Personally identifiable information leaking into logs has long been a major problem. Most logging systems push requirements for fixing PII in logs back to the originating system. Cribl puts administrators in control, so they no longer have to rely on developers and vendors to fix problems in their logs. In this example, I have a business event being output from my middleware. This event is very rich, with lots of key value pairs. Splunk does well with this event in its key equal value format, but as I'm browsing through the data, I notice a few problems. Since my developers are basically just serializing the order to a log, they've accidentally included a credit card number and a social security number. I'm going to copy this event to my clipboard for use in Cribl later. In Cribl, I'm going to first create a new pipeline, which will be used for processing the data. Pipelines chain together functions which operate on the data. We're going to use a mask function for this. I'm going to filter to just source type equals business event because I don't know what might come down this pipeline in the future. Best to scope it to just one type of event. Next, I'm going to add a quick description. And now, let's pop out our expression editor to show you just how easy Cribl makes it to make sure you're masking your data right. I'm going to capture the key portion of the social security number and the value as separate capture groups. You can see the regex editor makes it interactive to see what my regex is matching. Next, we're going to add an expression to replace the matched data with. Expressions are JavaScript expressions. The backtick says we're going to use a JavaScript template literal, which allows us to access variables in a template-like language. For each capture group, Cribl creates a variable the expression can use called gNumber. So I'm going to keep group 1 as is, and I'm going to call cmask MD5 G2 on group 2. This is great. Now I can interactively see that I'm masking my social security number uniquely using an MD5 hash. But social security number is now much longer than it used to be, making my data look strange. We're going to add a second parameter to the MD5 call, which will use the length of the original string to do what is called a length preserving mask. Now I have data which looks roughly the same as before. Next, I need to clean up that credit card number that was in the logs. This is a serious problem for PCI and other compliance frameworks. I'm going to write a regex which matches all 14 to 16 digit numbers. On the right, I'm going to mask it similarly to how I masked the social security number, but we've got a minor problem. If you notice down below, order number has been accidentally masked as well. Cribl is fully programmable, and our use of JavaScript throughout makes it easy to write much more complex expressions. In this case, what I'm going to do is use a ternary operator to first check and see if the match is a credit card number. If it is, I'll mask the output. If not, I'll return the original text. That's cleaned up our problem with matching the order number accidentally. Now I return to the main screen of Cribl, and I'm going to configure a route to match all events with this source type and send it down the obfuscation pipeline. As we check in Splunk, we notice that new events are being transformed in the way we're expecting, and our data is secure again. Thanks for watching our quick Securing Your Data video. Check out the others in this series or go to cribl.io/download to get a copy of Cribl for yourself.